Good morning, my dear students. Welcome back to science again, and let us study the next part of the lesson, effects of electric current. So last time we have already finished one of the effect, that was heating effect of electric current. So today let us proceed with the next one, that is nothing but the magnetic effect of electric current. So in this magnetic effect of electric current, the name is magnetic effect of electric current, but we are going to study two things in this. That is one itself is MECC, that is magnetic effect of electric current, and the second one is electromagnetic induction. Fine. Now first of all you should know what is the difference between the two. So don't worry, I will try to make it very easy for you, right? Now, what is that, magnetic effect of electric current? First of all, children, listen. So, understand that when the electric current is flowing through the wire, it produces certain effects. One of the effect is heating effect, which you have already studied. And heating effect is nothing how it is generated. It's because when the electrons are in a current, current of electrons is flowing, some of the electrons collide with the other electrons, or maybe the atoms, other atoms. So when they are colliding, what happens is, due to friction, what happens, heat is generated, and this is only called as the heating effect of electric current. And because of this heating effect of electric current, there are so many equipments which are generated due to this. This is one of the very important discovery. It doesn't produce only the heating effect, but it also produces the magnetic effect of electric current. Fine. Now how is that? So whenever electric current is flowing, it produces some amount of magnetism wherever it is. When the current flows, you should remember that it produces magnetism. Very interesting, right? Fine. So you can see over here that current produces magnetism, that is magnetic effect of electric current, whereas electromagnetic induction is just the opposite of magnetic effect of electric current. How is it so? It is nothing but, here whenever there is change in the magnetic field, the current is generated in the wire. Fine. So it is correct, it is just the opposite. One is producing, current is producing magnetism, that we call it as magnetic effect of electric current. The other is, when you change the magnetic field around the wire, the current is automatically produced. Wow, very great, right? Fine. So now let us discuss this first, that is magnetic effect of electric current. How is the current producing magnetism? It is very simple. What you have to do is that same circuit what you are using mostly, that is, you have to take a wire, you have to take the to supply for the flow of electricity, or for the flow of electrons, you require potential difference, and that is given by a cell. Fine. And you need to know whether it is the current is flowing or not. For that you have to use any electrical gadget, and then only you can come to know that there is current flowing through the wire. Fine. Now when you have this circuit, let us try to bring a magnet near it, that is a magnetic needle. Fine. How we will come to know that the magnetism is produced? When the magnetic needle is there, it will deflect only when a bar magnet is brought near it, or a magnet is brought near it, it will try to deflect. Correct? Otherwise it will not. Correct? Fine. So that means only when the magnet is brought near the magnetic needle, it will start deflecting. Fine. Now let us see whether current is behaving like a magnet or not, or the current is producing magnetism or not. Okay, with a small experiment here. Okay, you can see that there is a wire and it is connected, and there is a cell. You can see this black colored cell is there. So it is connected to the cell, that means the current will be flowing. Only you have to press the key and bring the wires, connect the wire to the cell, then you will find that the current will be flowing. Fine. So once the current flows, whether there is magnetism or not, let us see here now. You can see this short experiment here. You can see whenever the wire is connected to one of the terminal of the cell, you can see that there is a deflection in the deflection in the magnetic needle, and magnetic needle will deflect only when the magnet is brought near it. Fine, here there is no magnet, but still you can see the deflection, right? So that means there is magnetism produced in the wire, and this effect itself of the current is called as magnetic effect of electric current. Fine. And who studied this effect? It was none other than Hans Christian Ørsted. Okay, so you can see the picture of Hans Christian Ørsted. So when he was, studying about he wanted to study whether current is producing any effect or not. So he had done the experiment, and he found that when the current passes through a metal wire, okay, the magnetic needle near the wire turns through a certain angle. So he pointed out here in this case the relation between the electricity and the magnetism, and he called this effect as electromagnetism or magnetic effect of electric current. So he was the one, Hans Christian Ørsted was the one who studied electromagnetism in the 19th century, around 1820. Okay, fine. Now that you have studied that what is magnetic effect of electric current and who has discovered it, you should always remember that whenever current is flowing, magnetism will be produced in it. So if you keep a magnet near a wire, it will, of course, magnetic needle will start deflecting. Okay, and now how is this, what is the direction of the magnetic field? That can be studied by using something called as right hand thumb rule, and there is one more rule related to this, okay, which is called as Fleming's left hand rule, which you are going to study in detail later on. Fine. So, and due to this magnetic effect of electric current, there is one equipment or one instrument which was generated, and that was nothing but the electric motor. Fine. Now this is regarding the magnetic effect of electric current. Second one is the electromagnetic induction. As I have told you, it is just the opposite of magnetic effect of electric current. Here the current produces magnetism, whereas in this case, whenever there is change in the magnetic field, current will be produced. Fine. So now let us see how this change in the magnetic field can produce current. So here what you have to do is that nothing, you have to take a wire, so as to for the flow of current we require metallic wire, right? We also require a bulb or maybe any other electrical gadget. So as to bulb will be a better option, or maybe some one instrument is there that is called as a galvanometer. So galvanometer is the instrument which is used to detect the electric current. Fine. So if you arrange equipment, the circuit like this, that is just a wire and a galvanometer or maybe a bulb, you can. There is no need of any electric cell. We don't require any potential difference here. We have to prove, or we have to see whether whenever there is change in the magnetic field, is the current produced. Let us see now. And now here you can see there is a coil of wire. Fine. There is a magnet here which is placed inside the coil. Fine. And there is an instrument called as a galvanometer. Fine. So let us see how the magnetic field can produce current. Galvanometer is a device which shows that if there is current, then the galvanometer will start to deflect from one position to another. So in the beginning it is at 0. Okay, and when suppose the current is flowing through it, it will deflect on the left hand side or on the right hand side. So let us see this now, how it is happening here. You can see when a magnet is brought near the coil, you can see that there is a deflection in the galvanometer. So this deflection, the galvanometer shows that there is production of the current. So current is produced here. Right. So the current is produced. That means whenever there is change in the magnetic field, when the magnet is brought swiftly near the coil of a wire, okay, you find that the galvanometer starts deflecting from left to right or right to left depending upon the direction of the magnetic field. Fine. So this shows that the magnetic field, change in the magnetic field can also generate current. Correct? So this principle was studied, or this phenomenon was studied by another scientist called as Michael Faraday. And there are laws of Faraday's, they are also called as Faraday's law of induction, that is electromagnetic induction. That means magnet is producing electricity or inducing electricity inside the wire. So this phenomenon was studied by Michael Faraday. This phenomenon was studied by another great scientist who was Michael Faraday. You can see. So remember, dear students, Hans Christian Oyster studied the magnetic effect of electric current, and Michael Faraday studied the electromagnetic induction. That means when the magnetic field is changed near a wire, there will be current produced. So these two great scientists, because of these two great scientists, there was invention of, one is the motor due to magnetic effect of electric current, and second one is the generator. Generator, how whenever there is current, there is no current, we have the tendency to put on the generator. So once the generator is put on, you can see that the current will be produced. Correct? So this phenomenon was studied by Michael Faraday. So these two great scientists, because of these two great scientists, there are so many instrument, motor, because of the motor, so many electrical gadgets are running, like fan, or maybe other refrigerator, washing machine, whatever it is. Every electrical gadget, most of the electrical gadgets are using the motor, where a generator is also required whenever, because the electricity is produced due to generators. Okay, and especially in the wherever the current, the light is generated. Fine. So so you understand that these two scientists have tried to study these two phenomena. Fine. So in the electromagnetic effect of electric current can be studied by the Fleming's left-hand rule. Okay, on the basis of which motor is generated, and the electromagnetic induction can be studied by Fleming's right-hand rule. Okay, so these two rules, and from right-hand rule only the generator was invented. Fine. So these were two very important discoveries of that time. Fine. Now that you have already learned now what is the difference between the magnetic effect of electric current and electromagnetic induction, let us know something, some basics about the magnet and the magnetic field. So why I am telling this is because you have to understand the further part of the lesson, and for that you need to know the basics of all about magnet and magnetic field. Okay, so you can see a picture over here. You can see in this case that there is a magnet, okay, and you can see some lines around it. Correct? So it is nothing but the magnetic field. So you know that, already studied that a magnet has two poles, that is north and south. Correct? So let us first know about a magnet, and then we will study about what is magnetic field. Let us learn about some basics about the magnet. You have already learned this before. Now now what is a magnet? A magnet is nothing but it is a material which attracts iron or iron-like materials. Fine. So you must be knowing about this, that the magnet can attract either iron or iron-like materials. Now these iron-like materials are nothing but the nickel and cobalt. Okay, and there is one more metal, that is nothing but gadolinium, also can be attracted by a magnet. Fine. So then we know that there are various types of magnets. You can see over here what are these various types of magnets, such as, you have studied about a bar magnet, there is a horseshoe magnet, then we have also a magnetic needle, then you know what is a disc magnet, then you have a ring magnet or oval shaped magnets or cylindrical magnet. These are some of the magnetic shapes. Fine. Then there are two kinds of, always remember there are two kinds of magnets, that is, one is natural magnet and the other is artificial magnet. So natural magnet, if you know or you have heard about it, I don't know, natural magnet was first time found in Magnesia. Okay, Magnesia is one of the place in Asia, and first at that time magnet was known as a magnetite. Okay, so that so magnets are found naturally inside the in the form of a ore or in the form of a mineral. Fine. So like how other metals are found, the same way magnets are also found. So it was first found in Magnesia, and earlier the name of the magnet was magnetite. Then there is another type of a magnet called as artificial magnet. Artificial magnet, as you know, it is made by men, and again these artificial magnets are of two types, permanent magnet and second one is electromagnet. Now just now what we are studying is nothing but the electromagnet. Okay, so this is regarding the types of magnets and what kinds of magnets are present. Fine. Then you know that you have already also studied that it has two poles, and these two poles can never be separated. Fine. So it is always having a dipole. That means if you take a bar magnet and if you try to cut it into two pieces, each of these two pieces will have a north and south pole, again a north and south pole. Again if you try to divide it into two parts, again that means four parts if you make, each of this part will have its north and south pole. That means you cannot separate the two poles. You can see over here a small picture I have placed here. You can see there is north and south pole of the magnet, and see the first magnet is divided into two parts. Again it has two poles, north south, south north, south north. Again they are divided again to 2 and to 4. Again you will find that the two poles of the magnet cannot be separated. Fine. So this is another thing what you have to know about the magnet. Fine. Then the third thing, you know that the like poles repel and the unlike poles attract. Fine. So you can see in the first case unlike poles are attracting each other, whereas like poles are trying to repel each other. So this is another thing what you have studied before. Okay. So these are some of the basic things about the magnet. Now let us try to learn about what is a magnetic field. So where it is present. So it is present, it is a space around the around any magnet up to which its magnetic effect can be experienced. Okay, and this magnetic effect is due to magnetic field lines. So what I can say is that you can see over here this picture, there is a magnet. Fine, and you can see certain lines here. So these lines are called as magnetic field lines. Okay, and you can see that the magnetic field lines will be, if you take a magnet, two magnets, or a magnet and a magnetic material, that means iron, cobalt or a nickel, when these two things, that is a magnet or a magnetic material, is brought in, you will find that there is attraction. But as you take it away from the magnet, you will find that the magnet will not attract. It's because it has a certain limit, or the space which is there around a magnet is limited. So if you take it further and further, you will find that the magnetic effect will go on reducing. So wherever these magnetic lines are there, magnetic field lines are there, there only there will be the magnetic field. Fine, and this magnetic field is due to this magnetic lines. You can see the lines which are drawn here, in the form of an arc. These are nothing but magnetic field lines, which together it is called as magnetic field. Fine. So the effect can be experienced only due to magnetic field lines. I hope so you have understood what is magnetic field line. So these magnetic field lines, we cannot see them. They are just imaginary, but they can be experienced. How they can be experienced? That is, whenever you bring a magnet, two magnets together, or maybe a magnet and a magnetic material together, you will find that they will be starting to attract. Correct? So this experience only tells us that there is something, there is a force, and this force is nothing but the magnetic field, which is due to the magnetic field line. So I hope so you have understood regarding what is magnetic field and magnetic field lines. Next thing is the magnetic field or magnetic lines, field lines will never intersect each other. So you can see over here that there are concentric circle of, there are two magnets here, and each one of them is having their own magnetic field lines, and these two magnets, when they are brought together, they are having their own concentric field lines. Correct? But do you see any field line of them, is it intersecting? No, they will never intersect each other. So this is another property of a magnet, that the magnetic field lines never intersect each other. Okay, so this is another point to tell you about the magnetic field. Now let us try to learn about how these magnetic field lines are there, or from where is the direction of the magnetic field. How this magnetic field can be, how is the direction of this magnetic field? So can we find out? Yes, surely we can find out. What you have to do is that nothing. You have to take a magnet, take some, take a magnetic needle. Fine. And magnetic needle, suppose if you keep this side north pole and this side south pole. So this side north pole, if you try to keep a magnetic needle, you will find that it will point in this direction. That means the magnetic needle is, the bar magnet is here and magnetic needle is here. So if the bar magnet's north is here, okay, the south of the magnetic needle will be here and north will be this direction. So which tells that the field lines, the direction of the field lines is from north. Okay, one thing. Second thing, if you try to keep it this side, again you will find that the north is in this direction, south is in this direction. If you try to keep it at another position, you will find that north is in this direction, south is in this direction. So what does it say? It shows that the direction of the magnetic field is from north to south in the form of a concentric circle. So you can see over here in this picture here, so where you can understand how direction of the magnetic field can be found. So you can see that the field lines are generated from north and they are moving towards south. Correct? So outside the magnet, the direction of the magnetic field is from north to south. So you can see that the magnetic needles are placed at different places, and you can see the red part is this side. That means the north is this side, it is moving towards the south. Okay, this is how the direction of the magnetic field is found. So direction of the magnetic field outside the magnet is from north to south. But if you see inside the magnet, you will find that it is moving from south to north. Remember, dear students, don't get confused. Outside the magnet, it is from north to south, and that only you have to remember always, that the magnetic field lines are directed from north to south. But if it is asked specifically, how is the direction inside the magnet, it is from south to north, inside, whereas outside it is from north to south. So this you have to remember. So now let us proceed little further, that you have understood about how is the direction. Direction is always from north to south outside the magnet, and inside the magnet is south to north. Now let us see here, over here in this case, how are the magnetic field lines. You can see how very nicely that the direction of the field is from north to south. Correct? Now you have already studied that the like poles attract and unlike poles, like poles repel and unlike poles attract. Now why is this happening? That also you will come to know now. You can see in this picture over here that in the first case the north and south pole are brought together, whereas in the second case you can see that the north pole and north pole is brought together. So according to the property of the magnet, it is nothing but north attracts the south and south attracts north, whereas north to north repel or south to south repel. How is this happening? You can see in this case. Just now you have learned that the magnetic field lines are moving from north to south. So in the first picture, if you see, the magnetic field lines are moving from north to south in the one magnet, and even when the second magnet is brought near it, the magnetic field lines are joining. Can you see? North to south they are moving. That means they are coming together, and because of this only there is attraction between the unlike poles of the magnet. Whereas in the second case, if you see, when a north pole is brought near north pole, you can see, you know that if suppose this is the north pole of this magnet and this is the north pole of this magnet, so the magnetic field lines will be always moving from north to south this side, and from here it is from north to south this side, and so you find that they are repelling. Did you understand why this is happening? It's because of the magnetic field lines. So this is regarding the basic of the magnet and the magnetic field. So the next video we will learn about the magnetic effect of electric current in detail, about the working of the motor and all. Fine. What is the right hand thumb rule? Then we will also learn about the Fleming's left hand rule regarding the magnetic effect of electric current. So till then students, bye and thank you.